Hello everyone, I am Dr. V. Swathi, Assistant Professor, Department of Mathematics and Management Sciences, VJEC. So today we are going to discuss the fundamental concepts of integration and differentiation. Here you can see real life meaning of calculus we will be discussing. So let me think about an ice cream. So think of an ice cream as a quantity that gradually changes as you eat it, right? Mathematically, if we take, let Q of t be the amount of the substance, the ice cream, at initially time t. And in general, we have a question, what is the instantaneous rate of change of ice cream being eaten? How do we calculate in mathematical perspective? Means this represents how fast the quantity is changing at a specific moment. If we want to calculate, that we will say it as rate of change of substance with respect to time. So instantaneously, particularly at the time, how much ice cream has been eaten. That we will take mathematically dq by dt. dq by dt. So here Q of t is the substance of an ice cream and which is getting changes a particular instantaneous time. So mathematically we call it as differentiation. And next, how much ice cream did I eat over time? So this one also we can represent in mathematical perspective. So this gives a total change in ice cream quantity mathematically, which is exactly we can calculate by integration. So here understanding of integration means accumulation of ice cream we will be calculated in two ways, what we have in our integration concept. So if we think about in general perspective, how much ice cream has been eaten up to at any time, there is no stipulated time period. So that can be calculated in the form of indefinite integral concept. So this represents, as you can see here, integration Q of t dt is equals to Q of t and some constants could be added. So whereas how much ice cream was eaten between the given time period, if you want to calculate how much ice cream we had eaten within the given time period, so within the boundaries t1 and t2, so we will be taking it as definite integral. So mathematically here integration t1 to t2 Q of t dt is equals to, so there is no summing up a constant because the time period has given particularly the lower limit to upper limit, starting and initial time has given. So this we call it as definite integral concept. And here you will get the result as amount of the quantity, how much amount has been eaten. And then we have a question, why we don't add a constant in general differentiation part. Every function has exactly one derivative if suppose that function is differentiable at a particular point. So here you can see an example, d by dx of x square minus 100. So what will be the derivative of this function? D by dx of x square minus d by dx of 100. So as you know, d by dx of x square is 2 into x power n minus 1 minus constant differentiation is 0. So the result will becomes 2x. And here the another example, this is first one and this is second one. Another example, if you see d by dx of x square minus 2 will become again 2x. So even though the functions are different, d by dx of the first polynomial x square minus 100 and the second polynomial from second example x square minus 2. So both are giving the same result, right? But the constant is not getting added in differentiation. Why? That is our question. So because here if you observe, the derivative concept means it measures rate of change in the function but not constant. So constants do not give any much effect. Okay. So but coming to integration, so integration is rebuilding the function, means total function we have to calculate. So here the same result whatever we obtain from the derivative concept from above examples, integration 2x dx is equals to, as you know the formula, integration x power n dx is equals to x power n plus 1 by n plus 1 plus c. Why? Because this is indefinite integral. Indefinite integral. So here integration 2x dx is equals to 2 into x square by 2 plus c. So here x square plus some constant is summing up, added. Okay. So here if you see differentiation concept for any different polynomials, if we having same degree, so x square plus 5 and x square minus 3. So through the derivative concept we are getting the result as same and constant is disappears. So whereas integration 2x giving the integral total sum of the function x square plus c means many answers are possible, constant must be added. So if we apply in general, so differentiation again we will go for an example. So differentiation gives eating the cake. Okay. So you lose toppings and the toppings should be considered as constants. So these disappears when you are eating the cake. So while we are reforming, like integration means trying to rebuild the cake. So you do not know original toppings, but the function should be rebuilt. So you add plus c constant, it doesn't much effective. In differentiation, toppings disappears, means in integration we add plus c because we don't know the original topping. And the topping should not affect the original shape or original quantity of the amount of the substance. So differentiation removes constant, so integration adds the constant plus c to recover them. And here mainly the constant c represents that any constant that could have been lost. And here integration as inverse of differentiation. So any function if we take f of x, so after derivative it becomes f dash of x, and this process where when we are splitting it into finite elemental parts, so that we call it as derivative, and from each and every splitted parts and making sum up into the original function, we call it as integration. So you can see here integration is the process of finding the total by adding infinitely small parts. So whereas differentiation is the process of finding how a quantity changes at instant by breaking it into infinitely small changes. And from graph you can see here the left part differentiation represents rate of change of the curve y is equals to f of x. And here whereas right side part graphical representation gives integration, means area under the curve. So here rate of change of the curve y is equals to f of x. So if we want to take first derivative, that is y dash is equals to f of x. So this gives change slope of the curve. Okay. So if we take y double dash, the second derivative of the slope, the second derivative of the function f of x, which gives rate of change of slope at a particular point. And whereas the integration, so here for any irregular shaped area, we want to calculate sum of the area through the integration calculation. So area under the curve we can see from A to B there will be given initial and final boundaries. So here if we want to calculate whole area and the curve which is not regular shape, okay, so we first divide each and every part as a strip, rectangular strip. So infinitely small parts of this rectangular slips, total area we can calculate. If we take single rectangular strip, dx distance, width and length this is y, so y, and the distance is dx. So the area of rectangle is y into dx. So if you want to calculate whole area by adding up many infinitely broken this rectangular strips within the initial and final boundaries, we can take a to b y dx. The differential represents a very small change in a function when input changes by a very small amount. Like if we want to take f dash of x, that is d by dx of f of x. So suppose if we take y is equals to f of x, okay. So here x as independent variable and y as dependent variable. So y depending on x means small change of x will affect a dependent function y. Small change in dependent function. Suppose if we consider, let s of t be the position of an object. Okay, initially at time t, the position of an object is s of t. And if we want to calculate velocity, that is ds by dt, distance with changes with respect to time. So that we will be taking as s dash of t. And rate of change of velocity, if we want to calculate, that would become acceleration. So dv by dt. So we will be getting second derivative. As we have seen, the rate of change of slope of the curve. Means differential concept gives small change in output causes small change in input. And here we can see the examples. In general, motion by the calculation of speed and velocity, and population growth as time being increasing, or the population might be increases or decreases. And in the economic sectors also, profit, cost, revenue, all are depending on time. And the temperature effect also. So we can calculate by the concept of differentiation. Next, coming to integration concept, the area under a curve represents total accumulated quantity of a function over an interval. Integration is mainly used to find the area of irregular shapes where simple geometric formulas cannot be applied. So for a function y is equals to f of x, from initial point x is equals to a to x is equals to b, we can represent mathematically integration a to b f of x dx. Each small rectangular strip under the curve gives a tiny area, that is just now we have seen f of x dx. Adding all these tiny areas gives the total area. So example point of view, integration concept could be useful distance from velocity. So if you want to calculate distance over the velocity v of t dt. And one more example, total water filled in a tank, total rainfall over a time, total profit over time. These are the examples. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.